Kyle, will you give me a cue when the live stream is?
Yeah, I'll give you a thumbs up. You have to do like a 3-second countdown.
Okay. We'll give it like 1 or 2 minutes. People filtering in online and whatnot. Yeah. Okay. Sure. Yeah. All right. Hello, everyone, and welcome. Thank you for coming. Thank you so much for the National Tech Council for allowing us to put this on and sponsor this event. We're very happy to be here. I'm personally grateful for the opportunity, so thank you all for coming out. Today, I'm going to be talking to you a little bit about what the regression gap is, what we mean by that, and how we can close it with test automation. You can consider this a guide to increasing your velocity. So before I begin, I'll start with a brief introduction to myself. My name is Michael Dailey, and I have had the pleasure of leading our amazing solution engineering team here at Provar. I've been in the DevOps space for around 6 or so years, and I've had several roles throughout that time period. I started out as a software engineer working at NES under Zycron, doing a lot of .NET and C# development. That kind of migrated into more of an architectural role. I started building out and kind of developing our infrastructure for DevOps and working on automation, that kind of thing. So that's really how I first discovered Provar, really, and my discovery of test automation as a whole. I began my career here with Provar about 3.5 years ago in April of 2019. I do live in Nashville currently, about 10 miles east of the city. I enjoy walking my dogs on days like this, particularly are very nice. I enjoy traveling with my family, and I pretty much love anything that's nerd related. Star Wars, Lord of the Rings, I'm all about it. So that's kind of about me, but enough about me. Let's talk about testing. So we're going to go through a brief little thought exercise before I kind of explain what this is. I want you all to kind of think back to the first application or the project that you were involved in. At the beginning, everything was new. Their initial phases were really exciting, and they were really filled with anticipation about what you could possibly be working on and developing and improving. Later on, however, you may have discovered that improving that application or project became a bit of a chore. Over time, each update and change came with its own baggage, right? And then the scope gradually grew as you continued on. Even more over time, you may have begun to dread new application updates or releases since they become more of a burden to test over time. And ultimately, they become more of a burden to approve and release through certain change management protocols. So this whole exercise that I just kind of went through is really just illustrates what we refer to as the regression gap. Regression testing is the process of testing something that has already been tested. More specifically, the regression suite is something that is completely new when its initial phase here. So if you look at release 1, everything is white there because it's all new. The next release is when you have mostly something that's already been in the code base or the configuration base, and then you're building on top of that what's already there. But as each release comes out over time, the need to test those changes doesn't change. You need to continually test things that have already been tested because as you introduce new features and updates, you need to make sure that you're accounting that you're not breaking anything that was already existing. So the real challenge really comes in the later releases and how do we keep up with that? So that gap that we're talking about, that scope gap, that's the regression gap. So what are our options? How do we close the gap? So option 1, we can add more time for testing. Wouldn't it be great if we just had an additional 40 hours in the week to get everything done, right? This is one of those things that is not necessarily scalable. It's also not sustainable. As you can imagine, we can't just continuously add more time in the testing cycle. As you add more time in a testing cycle, the regression cycle itself also gets extended. And then your ability to release changes at a regular cadence is going to decrease. So it slows down your release process and it ultimately consumes more QA time. Option 2, you can add more testers. Just hire more resources to get your testing done, right? Maybe one person can't get the job done, so you hire another person. You think, oh, if I have one person, if I have 2, then I can get double the work done. As we all know, that's not always the case. And in fact, most of the time, it is definitely not the case. It doesn't scale and it can be costly. So those are the 2 kind of drawbacks to that particular approach. So option 3, and this is why I'm here, and this is the one that I'm very passionate about. So option 3 is automate. What does that mean? I'll talk more about that. But automation is one of those things that we typically refer to as kind of this, black box kind of thing. You don't really understand what's going on. And it's one of those things that seems very technical and hard to understand and how to set that up. So I'm going to talk a little bit more about what automation is and kind of the different approaches to it. But first, I want to give a brief definition of what automation is when I'm talking about it in this context. So in general, the automation is the practice of running something, a repeatable task, automatically. In the context of test automation, it is no different. You're creating a test case that you intend to run on a repeatable cycle automatically. So talking about the benefits of automation, what are some of the benefits? So firstly, I want to talk about the consistency. So obviously, if something is automated, it's going to be more consistent. You're going to get the same result every time. If you have something that's done manually, there's human error involved. And it becomes more and more likely that someone may make a mistake, especially if you hire a new resource and you expect them to go through a certain flow. Not everyone's going to interpret that or do it the same way. The second point here is really the accelerated regression, which is kind of the biggest thing that we're talking about today as far as like velocity. When we talk about velocity, we're talking about our ability to release changes faster. So that's what we mean by that. So accelerated regression means you have less time devoted to testing because you're doing a lot of that you were doing manually before through an automated process. I want to tell a brief story of kind of one of our case studies that we had with one of our clients where they had a regression cycle. They had 10 QA resources that they dedicated to a project that were taking basically a 2-week testing period, which totals out to about 800 hours of work. And they got that down to 12 hours of work that was completely automated, that no one had to actually go and do that. So that's a lot of time that you're saving in terms of resources. So the last point here on this particular slide is the full autonomy. So what I mean by that is there's no human intervention. So when something is automated, you don't have to babysit it and make sure that everything is working correctly. It's fire and forget. You just press a button and off it goes. Or you could even schedule it. So there's one more reason, but I want to brief segue into my next slide here before I talk about that. and kind of lighten things up a little bit, make sure everyone's still with me. We talked about QA. I want to emphasize that QA is not boring. QA is really an interesting role because you get the opportunity to be very creative. You get to think about ways that things are going to break. So I took a couple of these tweets here I wanted to share because I find them a little funny, and they're also very accurate, right? So if you look at the first one on the left, it talks about QA being an art form because you're really thinking about all the ways and scenarios that you can break something. Something that I'm very good about is breaking things, whether it's accidentally or on purpose, but we won't get into that. But the other one here, I'll just read this one because this is one of my favorites. It says, a QA engineer walks into a bar, orders a beer, orders 0 beers, orders 99999 beers, orders a lizard, orders -1 beers, and orders, I'm not going to try to do that. And then the first real customer walks in and asks where the bathroom is, and the bar bursts in flames, killing everyone. So that just illustrates a point that we can't possibly, as humans, think of every single scenario that exists under the sun. It's just not something that's scalable, and there's always going to be something that's missed. So that's where this kind of additional point comes in. So we talked about the benefits. I gave you those 3. The last one here that I'm adding is the reduces monotony. So what I mean by that is the daily chore of the job itself, having to do the same thing over and over again. That's what I mean by that. So not having to do those same manual regression tests every single cycle. You know, you release something or make a change. They tell you, hey, can you go test this real quick? They make another change. Hey, can you go test that same thing you just tested real quick again? That can get very monotonous, right? We don't want to have to do that every day. That's how you get burnt out. This all sounds great, right? So where do we start? So I want to talk about 2 different testing approaches here, and I want to illustrate them into these 2 different grids that we're looking at. So once you've decided to kind of think more about test automation, you have to consider what approach it is you want your team to take. So when you're looking at these 2 different approaches, on the left here you have, let's say you have an environment or an application that has a lot of different customizations. It could be custom profiles, custom record types, validation rules, workflows, tools, all these integrations, right? You do regular releases into production. You should really be considering test automation that is more declarative, specifically for testing something like Salesforce. That will ultimately avoid you having to rewrite your tests every time there's a change. Conversely, if you have something that's very out of the box, right? You don't have a lot of changes to it. You're using some kind of enterprise application like SAP or Salesforce, and you don't necessarily have a lot of customization, well, then you may be okay with doing something that's a little bit more manual because you don't expect there to be a lot of changes in those releases. On the right side here, we look at this a very different way. So regardless of how you've customized or created your code base, right, you may have very complex changes, and the risk of those not working correctly is very high impact on your business. So on the left side, we're focused on frequency. On the right side, you're focused on the impact of the business itself. So if you don't have a lot of complexity, you can consider the business risk or the impact of something going wrong. And then based on that, decide what level of testing is appropriate for your team. These 2 concepts together are what we typically refer to as a risk-based approach. So when you combine impact on the business and the frequency of changes, you end up with risk. So rather than thinking about code coverage as a metric, a lot of people will talk about code coverage and how much coverage you have of your test suite, right? We're talking more about risk-based coverage. So more about how often something is used from a frequency standpoint, and also what is the impact that particular feature or change has on the business as a whole. So those 2 things coupled together make risk. Okay, so I want to talk, now we talked about the 2 different testing approaches. I want to look at a brief little example here. So I'm going to pop some code on the screen. Don't get startled. But this is a quick little code snippet. It's doing something very, very simple. It may look very complex, but in fact, all this is doing is performing a login operation into Salesforce. This is a code-based framework known as Selenium, and it combines basically open source frameworks with pretty much any programming language you want to use. You can automate web-based kind of elements and workflows. So that's really what the purpose of it is. However, someone has to ultimately come up with this. Because it's open source, there's no direct support for it, so you pretty much have to figure out what it is you're trying to do on your own. And then, of course, you need a developer who's familiar with the framework and also knows Java or C# or Python or something like that. They ultimately have to build it out. And this right here is very brittle, right? It's very difficult to maintain. And more so, it's more difficult to actually expand upon it. So this is just one operation. But if we want to keep adding things, you get what's known as technical debt. You have a lot of code base that does a lot of different things, and it becomes kind of this monster, this giant spaghetti monster that you can no longer contain. Another word for this, obviously there's code-based testing, is imperative testing. And really what we're referring to is it's something that's very granular, and it defines something that should be tested. It's typically more code-based, or it's more of a generic framework such as Selenium. Oftentimes it is very technical way of doing it. So this is kind of option one when we're looking at the testing approaches. The alternative, and again, I always kind of give you the bad news first. You'll get used to that flow. The good news is there is an alternative. So this little quote here is actually from our recent white paper that we released on declarative testing. And the Gartner poll basically said that spending on low-code platforms will exceed $20 billion by the end of this year. So really, low-code platforms are kind of, rising in popularity and have been for some time. If you're familiar with Salesforce, you know that's kind of how they got their name, right? Their whole no code or no software or low code. That's been their moniker for a very long time. Less code, more clicks, or clicks, not code, rather. So declarative testing kind of couples with that. Declarative testing, put simply, is what to test. What are we testing, right? Stop thinking about the granular level of, the fine-tuned details of what it is you're doing. Imperative testing is kind of that, but declarative is a little bit more all-encompassing. In a declarative testing framework, you test the application the same way that you would use it. So rather than going behind the scenes and trying to figure out what the code needs to be, run it, debug it, and then see how it behaves in an actual real-life environment, declarative testing, just like declarative programming, happens in an environment kind of parallel to what you're doing. So rather than doing something behind the scenes, you're doing something that's very similar to what you would be doing in your normal day-to-day life. And the last point here, I mentioned this, is it is a point-click configuration and customization. So ideally, you wouldn't need to know or understand any kind of programming language to be able to build out a declarative testing solution. So this is a brief little example, and this is our application, Provar, which illustrates kind of a very simple process. Excuse me. Apologies if it's not immediately visible. But basically what this shows is just a simple action of how to add steps that a normal user would perform in a web-based application such as Salesforce. So this is what I mean by declarative. There's no code that's being written here. There's nothing that's happening behind the scenes. You're looking at Salesforce and you're building out whatever it is your automated test case is right alongside it. All right, so I want to go back to the code-based approach, looking more at an imperative solution. So comparing these two approaches, right? So we have imperative or code-based, and we have declarative. What are we left with then? So what's the pros and cons of each one? So we look at imperative. They offer very minimal transparency, right? There's not a lot of understanding what's going on. So I use this little matrix screen to kind of illustrate the fact that it's more of a black box, right? We don't necessarily know what's going on behind the scenes. The next point is it doesn't offer a lot of maintenance improvements because there's a lot of high maintenance when it comes to managing the technical debt over time. It's only going to get bigger. Your framework is not going to get smaller over time. It's only going to continue to increase as you add more features and need to add more test cases into your regression cycle. Another point here, which is very important in our context especially, is that it lacks product awareness. Because most imperative or code-based solutions are generic, meaning they're meant to be applied across everything, right? They have no real niche. They're kind of just, we want to do everything and we want to do everything okay. The jack of all trades, master of none, kind of that. But it's not necessarily aware of the product that you're testing, right? So there's no like inbuilt or native functionality to help you test those products more seamlessly. Also, the UI changes can be painful. So going back to that code snippet that I shared with you, that login flow, very, very simple flow. But if any of those elements were to change, like if someone changed an ID or they added another field or something like that to that login form, then those UI changes could be pretty painful, and how to improve that and how to include it in the testing. And obviously, it is the opposite of what we want in today's world. It's very code forward and not a lot of click-based configuration. Okay, so again, looking at the bright side. So what are the benefits in comparison to declarative versus code-based? So the tests are going to be human readable. It isn't a black box. When you look at the test steps, you're not looking at a code-based, you're looking at something that is more human readable. Obviously, you can look at it and see exactly what it's doing. It'll say what it's doing, rather than say, some method or some operation in some programming language that you may have to understand, at a deeper level. It'll just say, click this button, log into this. It's very much intuitive. And a big thing here is lower maintenance. And I kind of alluded to this in the beginning when I talked about that regression gap over time. So the maintenance costs are going to be reduced significantly because you don't have this technical debt that just keeps mounting up over time. Not only can you maintain them also with non-technical users, but you don't have to update them as often due to their nature that they're very dynamic and they're very configurable. If you do need to make changes, they're very easy to make. Product awareness is a big one. Whether or not you use Salesforce, I would encourage you all to, if you do any kind of exploration into test automation, find a tool that is product aware. Find something that has some kind of native functionality to help you test whatever it is you're testing, right? You want to not have to build your own framework from the ground up, because a lot of people have tried that before, and as you can imagine, that ends up becoming its own beast. It's very UI agnostic, and what I mean by that is it doesn't care if there's changes in the interface. If you make updates to your application, ultimately your tests are not going to break. That's what you really want. You want your regression tests to continue to pass. You don't want to have to keep maintaining them after every release and making changes to them over time. So it doesn't really care what you're doing in the UI because the tests are robust and they're built to handle those kinds of changes. And exactly the opposite, it offers a clicks, not code interface for authoring and maintaining your test suite, so you don't have to be an engineer or developer to necessarily build out these test cases. Okay, so what is all of this giving us, the ability to do? So we have manual resources that are now, their tasks, most of their tasks are being automated. So what do they do now, right? We haven't replaced them. I'm not trying to say that. In fact, what we've given them is the ability to go and do more useful tasks. So what are those tasks? Well, I'm glad you asked. So we can free up the QA to do something a little bit more exciting and interesting, and that is what we refer to as exploratory testing. Now, besides that, they could also just, go walk their dog or take a lunch break, or they could actually get 8 hours of sleep because they're not having to stay up all night and test these changes. But aside from that, we want them to be doing something that is more job related. So exploratory testing is kind of the solution there. Now, what is exploratory testing? What is this guy talking about? So exploratory testing is one of those things that really is the out-of-the-box thinking. It's something that's not necessarily a defined process, right? You have your regular business flows where someone logs in. Let's say you have some kind of e-commerce application where you're purchasing items, you're adding them to a cart, and then you're performing some kind of transaction, right? So that's a basic flow. But what if someone doesn't follow that path, the happy path as we call it? What if they go off script, So exploratory testing is built to handle those kinds of things. It's very time boxed, so you shouldn't spend all of your time trying to find out all these different scenarios. You should come up with some kind of a time box for that. And it has a very specific objective. And honestly, this is my favorite part, limited documentation. I hate documenting things. So we don't want this to be like a regular thing. It should always be something that's new and changing over time because you're trying to find these new scenarios. So how do you begin with this process? So you start by basically describing what parts of the system need to be tested. What part of our application are we responsible for? And then testers employ creativity to basically explore and find those results. So what are the results that they're getting from testing those different parts of the application? Now, another kind of word for this is edge cases. You've probably heard that term before when we talk about edge case. It's something that doesn't always happen. It's kind of something that's off the beaten path, right? It's one of those things that maybe you have 1 million users and this one person did this one thing that broke something, but now that you found that, you can't ignore it and you have to fix it. That's the edge case, right? And it's those scenarios that aren't seen in day-to-day work. Obviously, it's best to do this collaboratively. So rather than having one guy go off script, and build out these exploratory tests, it's good to collaborate on these and come up and brainstorm different ideas. And also, what is important? Think about for future iterations, what are we focusing our time on? So again, just to kind of summarize here, exploratory testing has incredible value, I believe, and it's the kind of thing that we really should be doing more of if time allows. And importantly, it could never really be automated. It's one of those things that we don't necessarily have an automation for. It's one of those things that you need that QA mindset. Going back to the tweets, right? You need someone who's thinking out of the box, someone who's thinking about QA as being an art form. Okay, so continuing on. So I've talked a little about testing approaches. We've talked about exploratory testing. We've talked about declarative and code-based test automation solutions. So how do we go about choosing a test automation tool? There's a basic guide here for how to go about that process. The first one here is you want to list out all of your requirements and basically figure out what the priority on them is and think about what your teams are going to be using the most in terms of those tools' capabilities, right? What do they need to be able to do in order to perform their jobs? The next thing is to narrow it down, basically insert your solutions to something that is aligned to whatever product roadmap that you're wanting to test. So this goes back to my product awareness. You want to be using a tool that has knowledge of something that you're testing. You don't want to be inheriting something that is generic or maybe doesn't make any updates to account for the changes that those applications are making. In the context of Salesforce, it makes sense to consider test automation solutions that are Salesforce focused. If you're wanting to test Salesforce, that logically makes sense. There's also a really great checklist here. For those of you who are familiar with Salesforce, Ben is a blog that is independently managed by Ben. And he came up with a checklist of what is test automation in Salesforce and why does it matter. You can actually just Google that phrase and it'll come up there. That's a really good checklist to start from. And I would definitely recommend that resource if you're not really familiar with how to go about that process. The last piece here is you'll want to start organizing all of your demos. So once you've kind of narrowed it down, you've prioritized, you figure out what your requirements are, and you have a vendor list, I would always encourage you to have at least 3 options. It's typically what we recommend when you're looking at vendors. You want to start organizing all of your demos and your proof of concepts and do your due diligence, right? You want to ensure that they all meet those criteria and kind of do a comparison from there. And I've included our link there too. So, all right, so to summarize, we talked about closing the regression gap with test automation, talked about what regression gap was and how we can close it. We talked about how it can ensure consistency, right? So automation, the whole purpose of it is it's something that's repeatable, something that you can do over and over again. We talked about how accelerating testing is a good thing because QA no longer becomes a blocker. How many times do we have a 2 release cycle and maybe 2 or 3 of those days are dedicated to testing, but hey, we're not done testing this, we have to push our release back, right? We don't want that to happen because that's the opposite of what we want. We want to increase our velocity. So doing that, test automation can help with there. And one of my favorite points is really it frees up the testers to do something that's a little bit more valuable and interesting, and that's exploratory testing, right? So not the day-to-day tasks that tend to be a little bit more monotonous and mundane, but getting to do something that goes a little bit, beyond their regular workflow. The next thing we talked about was declarative tools and imperative code-based tools and how they improve upon something that has already been done. So I want to kind of reiterate that. Obviously, everything started, everyone was doing something that was code-based. But basically what declarative tools have done is they've packaged that and they've built frameworks around those code bases so you don't have to manage it yourselves. That's really the whole purpose of it, right? We don't want to have to maintain the code ourselves. So rather than do that, we rely on the declarative tool. Declarative tools ultimately produce easier to read and understand tests. They are human readable. It's something you don't need to be an engineer to understand. So that really helps when we talk about hiring new resources and collaborating across teams. It is Salesforce aware, or if you're not using Salesforce, something that is product aware, something that knows what's going on. It's not generic. It is aware of the different applications you're using, and it has native functionality to help you test those applications, to make your life easier ultimately. And the last point is lower maintenance, right? Maintaining technical debt over time is something that is obviously going to increase costs, and that's something that we want to reduce. So, and the last point here, my actual last point, forgot I had this one. So it solves a technical challenge that maybe is something that has already been done. So this is something that I kind of added in here because I'm really thinking about if you're using something that's generic, right? You have to a lot of times figure out how to do something, reinvent the wheel, look on Stack Overflow or Google, how do I do this in this particular application? Chances are someone's done it before. So declarative tools, that's another thing that they often solve for. Those technical challenges that take a long time to figure out how to solve, they've already done that for you. So that's really something that could be a big benefit here. In the context of Salesforce, if you're looking at it like a migration from Classic to Lightning, those kinds of technical challenges are huge, right? Like how do we test our Classic version versus our Lightning version of Salesforce? Declarative tools account for that. So what are the next steps? So we talk about next steps. I would encourage you all as kind of a takeaway to review your internal testing practices. What is your team doing today? How much time does the regression testing take each release? I go back to that 2-week, or maybe you have a 4-week, or whatever your sprint cycle is. How much of that block of time is dedicated to testing, right? How quickly is the scope expanding or that regression gap increasing over time? So basically, how much is what you're testing going up over time, right? We want to keep track of that. And the last point here on this particular item is, are you finding time to do that exploratory testing, right? Are you having time to go and find those edge cases, those things that aren't typically tested on a day-to-day basis? So another next step here is thinking about the testing approach. So once you've kind of done an internal review, what approach works best for your team? So thinking about that is a question here. Can we afford to stay manual only? Obviously, people typically say manual is free, right? We don't have a tool, we don't have to pay for it. So it's something that we're doing. We can already do that through a manual resource. Why would we purchase a tool or do anything different? Well, as we all know, that time is money. If a resource takes time to test something manually, that's costing your company money because you're having to pay them to do that. And next point here is, do we need an automation strategy, right? So do we need to come up with something that's, an actual formalized testing strategy, and how do we productionize it and get it across the board? Make sure that everyone's on board with it, that kind of thing. So before I leave with this particular point, I did want to share some helpful resources that I've thrown in here. So here they are right here. So I already talked about the first one, and it's talking more about the checklist that I referred to. So what is test automation in Salesforce and why does it matter? And the next one is 5 steps for evaluating a test automation tool. And you can actually just Google these. If you Google these phrases specifically, then it'll come up with the relevant articles at the top. So you should be able to find those. The last one there is actually the white paper that we had on declarative testing. So if you want to learn more about that, that is a great resource. So I'm going to actually go back to my previous slide, a bit out of order. And with that, that's all I had for today. I will open it up to questions, either live audience, and then we'll have those of you watching online can comment and leave a question if you have one, and we'll get to that. Nothing online? You sure?
You were that good.
All good? Okay. Well, if that's the case, then I will say again, thank you for attending. Here are some ways that you can reach myself. There's my LinkedIn, a bit.ly link for that. But you can also just Google Michael Dailey, LinkedIn, and if you recognize my face, it should be on there. And that's also my GitHub. I have a lot of public repos that I like to share about how to do things. So, yeah. Again, thank you all for hosting, and thank you for attending. That's it.